Imagine standing beneath a tunnel so massive that a skyscraper could fit inside it, while a machine larger than a blue whale quietly cuts through solid rock beneath your feet. These underground highways, metro systems, and future transportation tunnels are not just holes in the ground. They are some of the most advanced engineering projects humans have ever created. But here's what nobody tells you. The future of tunnels is being built today with robots, artificial intelligence, and machines that can literally think while they dig. You see, building a tunnel is not simply about digging a path from one place to another. Every meter requires thousands of decisions about geology, pressure, temperature, materials, safety, and precision. Think about this. Some modern tunnel boring machines are longer than a football field and can weigh more than 5,000 tons. And before the first machine even starts moving, an enormous global supply chain begins hidden far away from the construction site. Most people never think about this, but a future tunnel starts thousands of kilometers away from where it will finally exist. The steel, copper, electronics, cement, and specialized materials travel across continents before becoming part of a machine that can reshape the Earth. And this is where it gets truly extraordinary, because the first step of tunnel technology begins deep inside the planet itself. The journey begins inside some of the world's largest mines. Iron ore from countries like Australia and Brazil provides the foundation for the steel used in tunnel machines and reinforcement structures. High-grade iron ore can contain around 60 to 65% iron before processing, and millions of tons move every year through massive mining operations that never stop. But the surprising part is that even the smallest component inside a tunnel machine may have traveled through several countries before reaching the final factory. After extraction, raw minerals enter massive processing plants where crushing, heating, and refining transform rock into industrial materials. Iron ore can be heated above 1,500 degrees Celsius, or 2,732 degrees Fahrenheit, inside blast furnaces to create molten iron that eventually becomes high-strength steel. The sound is unforgettable, thousands of tons of machinery moving, flames roaring, and glowing metal flowing like a river of fire. But steel is only one piece of the puzzle. Future tunnel systems also depend on copper, rare metals, electronics, and advanced materials. Copper from mines in Chile, Peru, and other regions becomes the nervous system of these machines, carrying electrical power through thousands of sensors and motors. Some tunnel boring machines contain kilometers of wiring and hundreds of electronic monitoring systems watching every movement. What happens next surprised even experienced engineers, because the machine itself becomes a factory underground. The materials then travel through one of the most complex transportation networks on Earth. Heavy steel plates can weigh several tons each, and specialized parts move by rail, ship, and oversized transport trucks. A single giant tunnel boring machine may cost between $10 million and $100 million depending on its size and technology. But the real cost is not just money. It is the precision required to make every piece work perfectly together. And there is another challenge hidden beneath the surface: the environmental impact. Mining and manufacturing consume enormous energy, create emissions, and transform landscapes. Modern tunnel technology now focuses on reducing waste, recycling steel, using cleaner energy, and designing machines that operate more efficiently. But before these futuristic tunnels can appear in our cities, every component must survive the most demanding stage of all, the manufacturing process. Now the real transformation begins. Inside a massive manufacturing facility, thousands of individual parts come together to create a machine powerful enough to carve through mountains. Think about this: a tunnel boring machine is not built like a normal vehicle. It is more like a moving underground factory with cutting tools, crushing systems, electrical networks, and robotic controls all working together. Every component must be placed with incredible accuracy because one tiny mistake underground can cost millions. The first stage is cutting and shaping the massive steel structures. High-strength steel plates are cut using advanced CNC plasma systems and robotic laser machines operating at extreme precision. The cutting process can reach temperatures above 20,000 degrees Celsius, or 36,032 degrees Fahrenheit, creating bright flashes of light and showers of sparks as the metal separates. Workers monitor the process carefully because even a few millimeters of error can affect the entire tunnel operation. After cutting, The steel sections move into welding stations where enormous robotic systems join the pieces together. Industrial welding temperatures can exceed 3,000 degrees Celsius or 5,432 degrees Fahrenheit, creating powerful arcs of light that look like miniature lightning storms. The welding robots move at controlled speeds, while skilled technicians inspect every connection because these joints must survive thousands of tons of pressure underground. Next comes the heart of the machine, the cutting head. This enormous rotating disc carries dozens of specialized cutting tools designed to destroy solid rock. Some cutting heads can spin at speeds around 1 to 10 revolutions per minute while generating thousands of tons of cutting force. Behind every rotation is a carefully calculated balance between speed, pressure, and rock conditions. But the most fascinating part is how the machine knows what it is touching. Behind the cutting head, powerful motors and hydraulic systems are installed. Hydraulic pressure inside these systems can reach hundreds of bar, allowing the machine to push forward against massive underground resistance. These systems move with incredible force but require extreme control, because too much pressure can damage the machine and too little pressure can slow the entire project. The machine is powerful, but intelligence makes it unstoppable. Then comes the installation of the digital brain. Thousands of sensors are connected throughout the machine to monitor vibration, temperature, pressure, and movement. Some systems collect data hundreds of times every second, allowing engineers to adjust performance while the machine is deep underground. Most people never think about this, but a modern tunnel boring machine is closer to a spacecraft than a traditional construction tool. Before leaving the factory, the complete machine enters a brutal testing phase. Engineers simulate underground conditions by applying pressure, vibration, and extreme loads to every system. Some tests run continuously for hours or even days, pushing motors, electronics, and cutting equipment beyond normal operating conditions. And this is where it gets truly extraordinary, because only machines that survive these tests are allowed to enter the Earth. Once approved, the machine is transported to the construction site and assembled underground or near the tunnel entrance. Massive cranes lift sections weighing hundreds of tons, while teams work with millimeter precision to connect every piece. The final assembly can take weeks or months depending on the project size. But the biggest challenge has not even started yet, because now the machine must fight the planet itself. When the cutter head finally begins spinning, the sound is unlike anything above ground. Metal bites into rock, hydraulic systems push forward, and thousands of sensors constantly adjust the machine's movement. The machine may advance only a few meters per day depending on geology, but every meter represents a battle between human engineering and nature. And what happens next reveals how technology is changing the future of underground construction forever. Deep beneath the ground, the future of tunnel technology is no longer controlled by human hands alone. Artificial intelligence, robotic systems, and thousands of sensors now guide machines through environments humans cannot safely enter. Think about this. A tunnel boring machine can operate in darkness, extreme pressure, and unstable rock while constantly making decisions based on real-time data. But the most surprising part is how these machines see, think, and adapt. Modern tunnel machines use advanced laser scanners and AI vision systems to understand their surroundings. These scanners can measure tunnel alignment with accuracy down to a few millimeters, detecting even small deviations before they become serious problems. Cameras and sensors work together like the eyes and nervous system of the machine, creating a digital map of the underground world. Most people never think about this, but every centimeter of a tunnel has a story written by technology. Inside the control room, operators watch hundreds of measurements every second. Temperature, vibration, cutting force, hydraulic pressure, and machine position appear on high-tech displays. If the cutter head experiences unusual resistance, the system can automatically adjust speed, pressure, and movement. The machine does not simply dig, it learns from the earth beneath it. Quality control begins long before the tunnel opens to the public. Engineers inspect every weld, every bolt, and every structural connection using ultrasonic testing, laser measurement, and automated scanning systems. Some inspections can detect flaws smaller than a human hair, helping prevent failures that could appear years later. The goal is simple: build tunnels that can survive for generations. But here's what nobody tells you: machines are not perfect. During manufacturing, some components fail inspection and must be repaired or replaced. High-end industrial systems often aim for rejection rates below a few percent, because every failed part can delay a massive project. Engineers follow strict international standards, including certifications for welding quality, material strength, and safety performance. Every approved component carries the responsibility of protecting thousands of lives. After inspection, the machine faces durability tests designed to recreate years of underground punishment. Engineers simulate vibration, pressure changes, extreme temperatures, and continuous operation. Some components are tested for thousands of hours before final approval. It is a brutal process because underground, there is no easy repair option. The machine must perform perfectly from the first cut. However, even with all this technology, one thing remains impossible to replace: human experience. A skilled operator can recognize a strange vibration, an unusual sound, or a change in machine behavior before software detects the problem. The best results happen when human judgment and artificial intelligence work together. And this partnership is pushing tunnel engineering into a future that once seemed impossible. The next generation of tunnels will go even further. Autonomous machines, digital twins, predictive maintenance systems, and smart construction networks are already changing how engineers imagine underground spaces. Future tunnels may repair themselves, communicate with vehicles above ground, and operate with almost no human presence. But before we see these incredible systems become reality, we need to understand just how enormous this industry has already become. The world beneath our feet is becoming one of the fastest-growing engineering frontiers on Earth. Every year, thousands of kilometers of tunnels are built for transportation, water systems, mining, energy, and underground infrastructure. The global tunnel construction industry is worth hundreds of billions of dollars, and demand continues to rise as cities become more crowded. But the numbers behind this hidden world are even more surprising than most people imagine. Today, countries like China, Japan, the United States, Germany, and South Korea lead some of the world's most advanced tunnel projects. China has become the largest builder of underground transportation systems, creating thousands of kilometers of metro tunnels across rapidly expanding cities. Japan has spent decades perfecting tunnel safety because of its challenging geography and earthquakes. These countries are not just building tunnels, they are building the underground cities of tomorrow. Did you know the world's longest transportation tunnels stretch for dozens of kilometers through mountains and beneath seas? The Gotthard Base Tunnel in Switzerland extends about 57 kilometers, making it one of the longest railway tunnels ever built. Projects like this required millions of tons of excavation and decades of planning. But the incredible part is not just the length, it is the precision required to connect 2 points deep inside the Earth. The technology has changed dramatically over the last 50 years. Older tunnel projects depended heavily on explosives, manual drilling, and large human crews working in dangerous conditions. Today, automated boring machines, GPS guidance, robotics, and AI monitoring systems have transformed the industry. The future is moving toward cleaner, safer, and faster construction methods that can create underground spaces with incredible accuracy. Did you know that some modern tunnel boring machines can excavate thousands of tons of material every day? The removed rock is often transported away on conveyor systems, processed, or reused in construction projects. Nothing is simple underground, even the waste from digging can become a valuable resource. This circular approach is becoming a major part of future tunnel engineering. Another surprising fact is how many people are connected to this industry. Engineers, machine operators, geologists, software developers, welders, miners, and safety specialists all contribute to every tunnel project. A single mega project can involve thousands of workers from different countries and industries. Behind every underground passage is a human story of planning, problem-solving, and teamwork. Looking ahead over the next decade, tunnel technology is expected to become even more advanced. Autonomous machines may reduce risks, AI systems may predict failures before they happen, and underground transportation could become faster and more efficient. Imagine cities where traffic disappears because entire transportation networks move silently beneath the surface. But the biggest question remains: how far can humans push the boundaries of underground engineering? The answer may come from the next generation of machines being developed right now. New designs are exploring smaller autonomous tunneling robots, faster excavation systems, and technology that could make underground construction possible even on other planets. Yes, future tunnel technology may not only transform Earth, it could one day help humanity build beneath the surface of the Moon or Mars. And that brings us to the final question. What does this incredible journey teach us about human invention? Think about this the next time you enter a subway station, drive through a mountain tunnel, or see construction happening underground. Behind those walls are layers of technology most people never see. Powerful cutting systems, AI algorithms, precision sensors, and materials forged at extreme temperatures. And this is where it gets truly extraordinary. The future of tunnels is not just about going deeper into the Earth, it is about creating smarter spaces for the future of humanity. But here's what nobody tells you. Every incredible tunnel begins with a single challenge: convincing solid rock to move. Humans have spent thousands of years trying to master the underground world, and today we are closer than ever. From ancient hand-carved tunnels to autonomous machines exploring new frontiers, our relationship with the Earth keeps evolving. The next breakthrough may already be waiting inside a factory somewhere, ready to change the world again. The next time you walk through a tunnel, remember the hidden world beneath your feet. Remember the roaring machines, the glowing steel, the engineers watching thousands of sensors, and the technology that makes impossible projects become reality. Because every tunnel is more than concrete and rock. It is a symbol of curiosity, courage, and the endless human desire to build what once seemed impossible. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the Earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.